Here is the banana plant's flower bud, emerging from the center of the pseudostem. Its broad leaves capture sunlight, while the thick pseudostem supports the plant's weight. The flower will develop into a bunch of bananas, a vital global food source. This powerful machine moves through the banana plantation, shredding the harvested stalks. Its rotating blades cut through the tough pseudostems, clearing the field for new growth. This efficient process is key to modern farming. We begin by chopping a fresh banana stem. The blade slices through the fibrous layers. Notice the moist texture and how it shreds. Each chop releases more of these tiny particles. The stem is now finely prepared. The hydraulic claw is positioned over the banana stalk. It descends steadily, the tines closing to grasp the stalk. Pressure increases as the claw secures and cuts the stalk. The plant is lifted away, harvest complete.
All right, systems are green. Monitoring the banana field. Deploying the arms. Target stalk identified on the map. Arms are in position. Initiating the harvest. Watch the precision cut. Bunch is lifting now. Perfect. Ready for the next one.
The grapple loader, holding a bundle of banana stalks, begins its descent into the container. Across impact, waters upward as the load settles. The wire releases, and the arm retracts, completing the efficient transfer. A crane grapple is hoisting a bundle of banana plant stems. The load is lifted steadily upward. Now, the grapple moves the bundle horizontally across the yard, a precise industrial operation.
This truck is loaded with freshly harvested banana stalks, ready for transport to market. In the background, the harvester moves through the field, cutting stalks from the banana plants. These stalks will be processed to extract the valuable fruit and other products.
The fleet advances through the banana fields. Dust rises from the tires as they maintain optimal speed. This precision operation ensures smooth transport through the vast plantation.
This is the Advanced Biber Facility, a pinnacle of modern industrial engineering. A fleet of trucks moves precision through this gateway, symbolizing efficiency and power. Every element is designed for optimal flow, driving the future of logistics.
This cutting-edge truck carries a vital cargo, banana plant stems. A high-tech scanning frame illuminates the load, their quality scanned in real time for precision. This is the future of agricultural logistics, efficient and sustainable. The trucks are positioned to unload the banana stems. The right truck is fully tilted, while the left one is still lifting. The stems fall into the pit, and the dust rises as the trucks empty. The conveyor belt is moving the banana stems at a steady speed. The motor is running at 96% torque and 120 RPM, ensuring efficient processing. The fibrous banana stems move smoothly, indicating the system's robust design.
The conveyor belt is operating at 150 RPM with the motor at 98% torque. The fibrous banana plant stems move efficiently through the system. This automated process is a constant flow for processing. The system maintains peak performance. This tunnel serves as a vital artery for agricultural transport, filled with banana stalks. Stalks are piled high, moving forward on a conveyor system. Moisture and vapor rise from the fresh harvest in the cool enclosed space. The scale is immense.
Welcome. Die Systemharvestenskämmer treater in the Ketterblatchers. Here, Osney machinery ends and processes the interfall applications. This ensures a steady supply of quality materials.
This vast facility processes bananas on an industrial scale. The conveyor belt moves the stalks forward for sorting and packaging. Automation ensures precision in handling the produce. This system represents modern agricultural efficiency. This industrial tunnel is a key part of the banana processing line. The conveyor belt system steadily transports harvested banana plant stems through the stems, thick and fibrous, move at a consistent pace, highlighting the scale and efficiency of this automated agricultural process. The machine's blade engages the moist banana stalk. It slices through the fibrous layers at a steady speed. Debris flies outward as the stalk parts. The cut completes, separating the stalk into sections. The cutting machine's blade is positioned over the banana stem. It descends at a steady speed, slicing through the fibrous layers. Sap and debris spray from the cut as the blade moves downward. The blade retracts, leaving two cleanly severed pieces. These thick sugarcane stalks are fed into the industrial crusher. The machine's rollers rotate, crushing the stalks to extract the juice. Water sprays help process the cane, producing a steady flow of liquid. This automated system precisely slices sugarcane stalk. The stalk moves along the conveyor as the blade descends. The blade slices through the moist fibers, separating the stalk. The process continues as the pieces move down the line. This factory uses advanced conveyor systems to transport banana stalks for processing. Automated machinery precisely handles and sorts the stalks, ensuring peak efficiency. The entire process showcases modern industrial innovation in agricultural production. Here on the conveyor, we process banana plant stalks. They're fed in from the left. We monitor the density and moisture in real time on this tablet. The system automatically sorts them for optimal processing. This ensures high efficiency and quality. The machine's large metallic rollers rotate at high speed, pulling the stack of sheets downward. The material compresses as it passes through the nip. This efficient process is key to large-scale manufacturing. This machine extracts juice from banana stems. The rollers crush the fibrous material, releasing a frothy, off-white liquid. The liquid flows continuously into the tray below after they're ejected. This efficient process transforms agricultural waste into a valuable resource.
This machine processes banana stems into fibers. The stem is fed between two metal rollers. The rollers shred the material into fine fibers. The fibers spread out and moisture drips away. This creates sustainable, useful materials. The banana stem material at 15.8% moisture moves along the conveyor. The blade then precisely cuts the material into smaller, usable pieces. These pieces are then deposited into a mixing vat for further processing. In this food plant, a sheet of dough moves steadily along stainless steel rollers. As it advances, a mechanism folds and layers the dough, building its structure repeats, creating a uniform, multi-layered product for further processing. This is the raw material, banana stem fibers on a conveyor belt, ready for processing. The fibers move through a series of rollers, which compress and align them into a continuous sheet. This process transforms agricultural waste into a versatile industrial material. This is the raw material, fibrous strands from banana stems on the conveyor belt. The belt moves them forward into the machinery. Here, rollers pull the fibers apart, separating them. The strands are then conveyed away for further use.
Welcome to the future of manufacturing. These robotic arms handle fibrous materials with incredible speed and precision. The system processes seamless integration, drives industrial progress, optimizing every stage of production. This facility houses rows of banana plants, their stalks hanging vertically in a controlled environment. Overhead create beams through the fog, illuminating the developing fruit clusters. This showcases advanced agricultural engineering. Welcome to this colossal facility, where innovation meets scale in food production. The conveyor system. The drifting vapor and shifting lights add to the mesmerizing rhythm of this automated wonder.
This machine processes banana stems with impressive speed and precision. High-pressure water jets remove impurities, ensuring a clean product. Real-time stats show a cleaning efficiency of 99.8%. This technology streamlines production for industrial use. A bundle of noodles is sprayed with water from a stainless steel nozzle. The wet noodles move steadily toward a large metal trough below. Water splashes as the noodles descend, creating steam. The process ensures clean, uniform strands for packaging.
This is a cross-section of a banana plant's pseudostem. The glowing blue formations represent the vital conducting tissues. Fluids and nutrients flow upward through these channels, essential for the plant's growth.
This is the fibrous pseudostem of a banana plant submerged in water. Observe the individual fibers, strong yet flexible, moving with the water. Bubbles rise, highlighting the plant's natural engineered structure, a testament to nature's ingenuity. In a massive industrial factory, a robotic arm lowers a huge dripping white mass. This mass is similar to the stem of a banana plant, fibrous and wet. The arm lowers it steadily, then releases it with a powerful impact. Here, fibers from banana stems are being cleaned inside a perforated container. First, the fresh stems are sliced open to extract the inner fibers. Then, the fibers are pulled and separated by hand for use.
This industrial facility transforms banana plant waste into high-quality fibers. The raw material, seen here on the conveyor, moves toward the processing oven. Intense heat and steam transform the fibers, creating a sustainable, versatile material. These are banana plant fibers being dispensed onto the conveyor belt. The fibers settle and begin their journey through the processing line. Notice how the strands align as they move forward. This efficient system transforms agricultural waste into valuable material. In this facility, the rope-making process begins. A digital controller maintains a stable temperature of 80 degrees Celsius. Raw fibrous material forming a stange of the rope fred interior machines. Here, strands of fiber are gathered and fed into the machine. The fibers twist together, forming a thicker, stronger rope. The rope is pulled and tensioned, increasing its density and strength. This process creates durable rope for countless applications. Here, gloved hands twist dried plant fibers to begin forming a rope. The hands pull the fibers steadily, adding more to lengthen and strengthen the rope. Finally, the rope is coiled for storage or use.
To begin, twist a small section of fibers clockwise. Keep twisting, adding more fibers to build the rope's thickness. Continue this process, maintaining even tension as the rope lengthens. Finally, braid the strands together for a strong, finished rope.
The process begins as light brown fibers are fed into the industrial combing and spinning machine. The fibers are combed and twisted into strands, which then converge to form a thicker rope. The formed rope is for industrial use as the machine monitors the process. The process begins with these golden yellow fibers being fed into the machine. Here they are aligned and stretched by these rollers. Next, they are twisted to form the initial strands of the rope. Finally, the strands are combined and wound into the finished rope.
In this factory, rope is made by spinning and twisting fibers. Rows of machines spin the fibers, which are pulled to the center. Here, the fibers are twisted into a strong rope. The finished rope moves down the line for collection. This spool unwinds golden brown fibers at a steady speed. The strand is drawn into the machine, where it's twisted into a strong rope. The rope then passes through tensioners to be coiled, completing the process. This robotic arm is placing a large spool of synthetic fibers onto a winding machine. The machine's drums rotate, pulling the fibers and twisting them into its high precision and consistent quality. Automated vehicles transport spools of fiber through the warehouse. At the machine, fibers are unwound from the spools. The fibers are pulled into a twisting mechanism. The resulting rope is then coiled, ready for use.